All right, so we're finishing 5, 6, and then this says to write each expression using rational exponents. So what we need to do is turn the radical into an exponent, and we know that rational, sometimes we can substitute what word for that? Rational means what? A fraction, yes, okay? So based on what we did yesterday, where we know a to the m over n is going to be the nth root of a to the m power, I can look at this and say, okay, my n, my root, is going to be 8. And remember that roots grow in the ground, so that's going to be the denominator in my fraction, whereas my power, or my m, is 4, and the power is going to be on top, which is the numerator. So this becomes 13 to the 4 over 8. Hopefully when you see 4 over 8, you get this little pang in your heart like, man, I know I can do something with that. 1/2. 1/2.
I'm so smart.
Okay, and you can leave this as 13 to the 1/2, but also keep in mind that 13 to the 1/2 is the square root of 13. Okay, if you could simplify that part, then you would, but this one doesn't simplify, so you're going to keep it as a rational exponent. Okay, now for B, did you say you didn't get pangs in your heart, or you did?
I got a pang in my heart.
Okay.
I had to simplify it.
That's
Sarah thought I was wrong.
Oh, okay. I like that. Okay, so then for this one, you're going to set it up similar. So 3 to the power, okay, be with me. You know I'm giving you this look. Language. So 15 over 5 is going to reduce to 3. Now 3 to the third power, you can simplify that. If it does simplify to a whole number, then you can leave it like that. Okay, so if it does simplify to a whole number, then you are going to simplify it completely. Okay? All right, and then let's flip it to the next page. Guys, do we need to break apart from groups, or can we handle this for one more page? All right, so properties of rational exponents. These should be familiar to you from Algebra 1. The first two we're going to talk about, the product of powers and the quotient of powers, is something we've also done this year. Okay, so my rule, if I have a product of a power, is if I have a to the m power and multiply that by a to the m, then I can add m plus n. Now they have to have the same base. Okay, so they have to be multiplied together with the same base, and then you can rewrite it. The quotient is if you have a to the m over a to the n, then you are going to subtract the exponents. Again, something that you already know. The power of a power is when you have one base, but an exponent is raised to another power. So it's a to the m to the n, and sometimes these two get mixed up. So I like to point out that in this case, you can see two bases. You can see a in both of them. Here, it's the exponent to the exponent, and that's when you are going to multiply. All right, now the next two, these can only be used if you have a product or if you have a quotient. So if you do have a product, such as a multiplied by b, and that quantity is raised to the power m, you can distribute it. It's a to the m times b to the m. I also want you to just note that a plus b to the m does not equal a to the m plus b to the m. That's not true. No. Because think about when you do squared. Remember, if it's a plus b squared, we practiced writing them out twice, and then you had to do what? If you have a plus b times a plus b, yeah, you're going to FOIL. Okay? All right, and then the power of a quotient. If you have a over b to the m power, you can distribute a over m to the b over m. Okay, so I wanted to make that note because that can be a common misconception. All right, now I want you to do these examples without a calculator. And the first one is 5 to the 1/2 power times 5 to the 2/3. The second one is 3 to the 2/3 over 3 to the 1/3. This is 3 to the 1/2 to the power of 2/3. This one is going to be the most amount of work without a calculator, but we'll do some of that together. And then 8 over 27 to the power of 1/3. Okay, so I'm going to give you some time now to get those done. So then once you finish the first one, I just want you to check in with your group to make sure that's what they got. Or if you are having trouble starting, you can ask your group. I'm going to come around so I can help you too. Wait, did you use your calculator? No. Okay, so.
Is that fine?
Oh, you said no, sorry. You said no, but I registered.
I thought do I need to
Okay.
distribute that first?
No, you could do it like that, but you probably aren't gonna wanna do the square root of 576 in your head.
No, not
Yeah, so if you are doing like
That's
the
why the
square
test
root
should
of
let us use a
9.
calculator.
No. On the test, that one's like a larger one.
So we can use a calculator.
Which means what though? Oh, but the 3 over 2 is going to be better for you.
I know, but I just like started it as the 2 over 3. Yeah, but
All right, let's see how this is going. All right, so even if you're not done, you can keep working quietly. I just need to make sure you did these right. So when you are adding, Max, when you're adding fractions, what do you need?
When you're adding fractions, oh yeah, you need to make the denominator the same.
Okay, so what did you guys make the denominator for this?
6.
Okay, good. So then you're going to have 5 to the power of 3 over 6 plus 4 over 6. And then you're just going to leave this as 5 to the power of 7/6. Okay, here you're going to subtract. Now this one is nice because you had a common denominator, and 2/3 minus 1/3 is something we can do quickly. So this is 3 to the power of 1/3. Okay, so 2/3 minus 1/3 is going to be 1 over 3. Here you're going to multiply. So this is going to be 3. 1 times 2 is 2. 2 times 3 is 6. 2 over 6 reduces to 1 over 3. All right, now for this one, you're going to start by distributing. So this is 9 to the 3 over 2 times 64 to the 3 over 2. Based on what we did yesterday, we know we can rewrite this as the square root of 9 to the power of 3 times the square root of 64 to the power of 3. Now, the square root of 9 is what? 3. So this is 3 cubed, which is 27. Now, this one is going to be 8. So 8 to the 3rd. This is the one where I was saying, oh, that if you were doing that without a calculator, that would take more work. But 8 to the 3rd is just 8 times 8 times 8, or 64 times 8. When you're trying to do that quickly, like in a PSAT environment, do you guys like doing the 60 times 8 and then the 4 times 8? It's just because that's something you can do fast. You know your multiplication facts because you're in honors. 4 times 8, 32. 6 times 8, 48. And then you're adding them together. So 2, 8, and 3 is 11, so 512. All right, so if we're doing 27 times 512, and we had to do that without a calculator, then I would write it out old school. You could also do the 512 times 20 and then times 7, which essentially is what you're doing. So 2 times 7 is 14, 1 times 7 is 7, plus 1 is 8, 7 times 5 is 35. Put in your placeholder. 2 times 2 is 4, 2 times 1 is 2, 2 times 1 is 10, and then add straight down. Earlier today I accidentally multiplied here, so just be careful of that. 5 plus 2 is 7, plus 8, and you'd have 13,824. Okay, the ones that you're going to do with no calculator are going to be maybe somewhere in between these two. So this one is actually really quick, because if it's 1/3, if you have the power of 1/3, Tyler, that's the same thing as doing what? Yep, so you're just taking the cube root of 8 over the cube root of 27. So then, Alyssa, what'd you guys get for your final answer? Good. All right, so now we're going to try this next set. Okay, again, you're doing that without a calculator, and really these ones are pretty simple to do without a calculator.
Yeah, I'm doing fine.
Look, bro, look. Over here. Yeah. Look. You see how this is 16 to the 1/4? Isn't that?
Yeah, I found this in my backpack and I was like,
Look, I'm wrong. I guess I'm wrong. 16 to the 1/4. No, you're
yep, we're past that. We're past that. We're moved up.
Oh, it's six. I'm sticking in the pipeline with it too.
I'm just going like 2.
What the?
And I got, it says 2, and I've got 8, and I've got 1 there. Wait, negative 2, negative 3. Yeah. Because it's negative 2 times negative 2 times negative 2 equals negative 8.
Okay, but so you're adding straight across. So 7 plus 11 is going to be what?
Yeah. Yeah, yeah.
Oh.
In your little mind, I went there. The final answer is 49.
All right, how are we feeling about this set?
I didn't like it.
Really?
No, I don't understand what I'm doing.
Okay, so in the first one, what did you do?
I did 7 plus 11.
Okay, yep, which was? Yep, so you have 18 over 9. 18 over 9 is?
7 squared.
Yep, which is? Yep, good.
It's the other ones I don't understand.
All right, so we'll have Rhea help us with this one. Okay, so Rhea, what'd you do first for B?
For B,
Uh-huh.
I did the 3/4 minus 5/4.
Okay, and then you got?
Negative 1/2.
Good. So this would be 16 to the negative 2 over 4, which would be 16 to the negative 1/2. Ethan, did you get there?
Yeah, I got to that.
Okay, so when you have a negative, Kate W., do you remember what to do to make it positive? Was that Alyssa? You look like somebody whispered you the answer. Was it Gigi? Okay, good. So, yes, you are going to use the reciprocal, and you're going to do 16 to the power of 1/2. Okay, so it's 1 over 16 to the 1/2. And then, Gigi, do you remember what we're going to do next?
Is the square root of 16?
Yep, good. So 1 over the square root of 16. So this is going to be 1 over 4. Totally. You said do not. You said you did not do those steps.
I said I totally did.
Oh. Wink, wink. All right. So then that might help you with part C. Okay. So, Ethan, what should we do first? Just based on what we did here with the negative exponent.
Take the reciprocal.
Yes. So write that down. Okay. So Max, can you write down the reciprocal? Write down the reciprocal for C. Okay, so if it's negative, you should have 1 over negative 8 to the power of 1/3. Okay, and then Max, 1/3 is the same thing as doing what?
Square root 3?
Uh,
I don't know how it's called.
I know, that's, I think I know what you mean, but that's not what you said. So if 3 is the index, it's the cube root. Okay, so tell me what you write here.
It's the cube root of 3 and then for the power of.
Nope, just cube root of. So if the power is 1 over 3, guys, will you listen to me, please? So if the power is 1 over 3, it's the cube root of, close, negative 8. Yep. So negative 8. That's okay. We just gotta practice. We just gotta practice saying it. All right. So this is 1 over the cube root of negative 8. The cube root of 8 we know is 2. The cube root of negative 8 is.
Negative 2.
Yep. So this is negative 1/2 is our final answer. And you can put your negative right in front there. Okay? Guys, I'll go over this one more time, but I need you to listen. So whenever you have a negative exponent, you're using the reciprocal and the power becomes positive. It's only the power that becomes positive. So the 8 stays negative, the 1/3 is what becomes positive, and then we did the cube root of -8 to get -2. So -1/2 is your final answer. All right, for our story problem, example 6, radium-226, that is the name of the element. It's a radioactive element that decays over time. The initial sample of radium-226 has a mass of 500 milligrams. So based on what we did in chapter 4, we were looking at radioactive elements that decay. And I remember that whenever it talked about an initial amount, that was something that's important. So that's probably something I'm going to want to highlight. So the initial sample was 500 milligrams. I don't need to highlight this number. This is the name of the element. The mass of the radium-226 that's remaining from the initial sample after T years, okay, so after T years, the mass remaining is given by, and then I'm giving this to you, 500 times 2 to the power of -T over 1600. Our question is, to the nearest milligram, how much radium-226 would be left over 800 years? And I'm just going to highlight this because this is telling me what I'm going to round to. All right, so if I'm trying to answer this question, the first thing I'm doing is classifying different information. So it says how much, so that is going to be the remaining mass. Okay, so what is the remaining mass? How much is left after 800 years, which I know I'm going to be plugging in for T. Okay, so this tells us that the mass remaining is given by this equation. So the mass remaining, what I'm trying to find, is equal to 500 times 2 to the power of -T over 1600, which this is the form of the equations that we looked at in chapter 4. So now I'm going to plug in okay, so now I'm going to plug in my T value, which was 800. And 800 over 1600 is going to reduce to? Yep. Okay, which we know from our last example is the same thing as 1 over 2 to the 1/2, or anytime it's to the 1/2 power, it's the square root of 2. Okay, if this question asked you for an exact answer, so if you were doing this without a calculator and you had to write an exact answer, we would multiply these together. Anytime you have a whole number, it gets multiplied by the numerator, and this is what we call an exact value. Okay, so if you have a story problem that asks you for an exact value, okay, this would be your final answer. Because we're rounding to the nearest milligram, we're going to divide 500 divided by the square root of 2 on our calculator. Now notice that the units they gave you, these were in milligrams. Okay, so when you divide, when you are rounding to this place, you're looking at the number after it. So the 6 is going to round this to 354 milligrams. Okay, so this is rounded to the nearest milligram. Okay, and that's what these directions say, so that's what I'm going to keep it as. All right. We're gonna do a couple of things now. I'm gonna give you some time to start your homework. We're gonna look at the calendar.